And I'm going to preface this by saying I was on a sort of meandering quest to understand what is this functional programming thing that people seem so friggin' jazzed about. And there's a lot of information on the internet. I deemed this credible based on the examples, based on the context that was provided, and based on the fact that it actually made sense to me. When people talk about functional programming, they mention a dizzying number of functional characteristics. They mention immutable data, first-class functions, and tail optimization. These are language features that aid functional programming. They mention mapping, reducing, pipelining, recursive currying, and the use of higher-order functions. These are programming techniques used to write functional code. They mention parallelization, lazy evaluation, determinism. These are advantageous properties of functional programs. Ignore all that. Functional code is characterized by one thing, the absence of side effects. If it doesn't rely on data outside of the current function, and it doesn't change data that exists outside of the current function. I'm not doing a very good job reading. Every other functional thing can be derived from this property. Use it as a guide rope as you learn. And then, from that point, I said, I'm going to implement this woman's Python examples in LabVIEW of how to translate some imperative code to LabVIEW code. And I started here. Don't. What happened? Plug it back in.
Yeah, you said Python. Problems with artificial intelligence.
Although it's not on the screen. How many monitors does it think I have? Oh, PowerPoint's open, so it's screwing things up. Quentin, I feel your pain. Where'd my mouse go? But it won't go on my other screen. Function F7. Thanks, smart guy.
It hasn't worked yet.
Oh, it's F8 on mine. Is that what?
Oh.
Windows P. Windows P.
What?
Windows Alt F4.
Bye. Duplicate. We got this.
Yes.
How many ACLAs?
All right. So what we're looking at, imperative code. We're doing some really basic things. The actual code runs a car race. All right, so we're just making dashes. And this journey was, this is an example, step by step, of how to refactor this from being imperative to being functional. Okay? So let's take a very quick journey through here. There's nothing really super exciting about this code. I put the original Python example from Mary Rose Cook's tutorial in the LabVIEW code. Like, this isn't terrible LabVIEW code, right? It's like pretty normal. We can all read this. Cool. But, oh, it's not good because it's imperative. So let's make it better by making it declarative, because that's better. It's going to run the same way. And I was as literal as I possibly could be in translating this from the Python syntax to the LabVIEW syntax. Wow, this is way better, because now I have like things that are separated, and I've got these variables I initialize at the beginning, and I don't have any wires connecting anything. It's really good. I use everything. Then I was like, okay, well, let's make it more functional. Notice it's still, what? Yeah, I guess we made it less functional. Okay. But the idea here is I'm drawing boundaries around the bits of functionality. What is a car race, right? It invokes these different actions that happen during a car race, like run, step of race, and then draw. And we've kind of separated the concerns of those things. And this is actually like a lot better than that middle step, right? It would be nice if it worked. I'll look into that later. I must have broken it when I was looking at it last night. And then we can go all the way fully functional, whatever that means. Maybe this one works. Yeah, cool. Where we're like, loops are the worst. I'm not going to use loops because they're so unfunctional. And I have this car race that looks a lot like the other one, but instead of having a loop, it recursively invokes race again if the condition of end of race is not met. You're like, that's kind of cool, but I think what I learned on this journey is that LabVIEW data flow is functional programming, right? This like new hot thing that people are talking about. I remember having these naive conversations years ago with other, curious developers about like, what would it look like if I wrote a functional VI in LabVIEW? It would look like a friggin' VI with wires going into it and coming out of it. Because wires are immutable data, and that's the most important concept of functional programming. That's the end.